Hey everyone, it's Mr. Canfield. Look at me. Oh, 0.5. Whoa. Oh. Okay. Everything you need to know for the marking period exam, marking period 4 exam. The only one of these I've done this year. Okay. So I'm just going to do every problem, and you just skip around to whatever you need. All right, here we go. So it's a simplify each sum. It's just a bunch of terms. Well, I see an x to the fourth. Let's see, is this? Yeah, okay. I see x to the fourth. Then I look for other x to the fourths. Here's another one. And another one. I think those are all the x to the fourths. And now I've got 1, and I've got -5, and I've got 4 of them. So this is a situation where literally go to your calculator if you can't do this. Like if you're struggling to do 1 minus 5 plus 4 in your head, just do 1 minus 5 plus 4. Remember, there's a 1 on that. Oh, and 1 minus 5 plus 4 is 0. So these actually end up canceling each other out, and there are no x to the fourths left. So I'm going to cross this out because I'm done with those now, and they're gone. All right, let's see what's next. You can underline. That's another way to do this. I see plus 4x. No, that's an x cubed. That's not it. 7x. Here we go. All right. All right, there's another x. So these are all just the plain x's, and I got 4 plus 7 minus 3. Again, if you struggle with that, I'm not going to repeat myself a million times with this, but go ahead and use your calculator. Actually, let me grab one. All right, so you could literally just go 4 plus 7 minus 3, 8. Okay. And that had an x on it, so it's 8x. And next I'll move on to, I see -2. So do I have any other plain numbers? Let's see. No, those have x's. Oh, here's a plain number. Here's another plain number. That's okay. So -2 plus 2 plus 7. And do -2 plus 2. That's not a 2. Wait, -2 plus 2 plus 7. I already know it's 7. All right, so then we got plus 7. And then let's keep going. Minus 4x cubed plus 2x cubed minus 7x cubed. Oh, okay. So -4 plus 2 minus 7, you get -9 x cubed. You can leave it like that, or you can rewrite it in standard form where you start with the highest exponent and you work your way down. So we've got x cubes first, so that's -9 x cubed plus 8x plus 7. So this is what we would call standard form of that answer, but either one's acceptable for what we're doing right now. So I'll go a little bit faster through the next one. We got 5x to the fourth, 3x to the fourth, and -7x to the fourth. So that's going to be 1. So you could write 1x to the fourth or just x to the fourth. You can put that 1 on the front. That's allowed. Now, I'm going to, instead of just going on to the next one, I know x cubed comes next. So let me see if there are any x cubed. So here's an x cubed. So I got -1 plus 4 plus 1. So plus 4x cubed. Now let me look for x squared. So this is, instead of just going from left to right, you can also just kind of hunt down the next one. So 3x squared, 4x squared, so that's 7. Minus 5 is 2. All right, so plus 2x squared. Now do I have any plain x's? No, all right. I see a plus 1, plus 6 is 7. Okay, I guess that's it. Now let me pull up my answer key just in case I'm making any silly mistakes along the way. I'd like to be able to catch those so I don't have foolishness in my answers. Hold on. Hey, I'm back. And I'm glad I did that because I made a mistake. So this is plus 1, and that said -8. So this should be a -7 here. So that's why it's always good for a person teaching to have their answer key so they don't make silly blunders. All right, let's keep going. So our next one, so it just says, remember to distribute negatives. So if there's just a parentheses on here and there's nothing in front, you can ignore the parentheses. That's not there. doesn't do anything. But now there's a minus sign on front of the parentheses. So we'll have to distribute that negative to all of them inside the parentheses, which really just changes the sign. It's a -1, multiplying by -1 changes nothing else except for the sign. So I can just say, okay, well that's negative now, that's negative, that's positive now, and that's negative. So that's kind of my personal way that I like to do these. You can rewrite everything underneath, but I believe the phrase is, ain't nobody got time for that. So here I have a minus of a 4, so it's a -4, a +5, a minus x, and a plus 3x squared. So this is the lazy way to do it. So I see an x to the 4th, so I have x to the 4th, and I just do what you were doing on the previous ones, right? X to the 4th minus x to the 4th, so they cancel, then plus 5 more, so 5x to the 4th. Next, we look for x cubed. I don't see any x to the 3rd. Okay, what about x to the 2nd? There's one, so I got plus 2 of them, minus 6 of them, that's -4, plus 3 more, that's -1. Nope, that was squareds that we were working with. Then x's are next, so I got 8 x's, 2 x's, so we're up to 10 of them, -1, we're back to 9. And then let's look for plain numbers. I got a 7, a -8, and a -4. So 7 minus 8 is -1, -4 is -5. Okay. So that's how we can do this without writing anything down. And I'm gonna skip the work on this last one, but I will write the answer for you. This is just tedious at this point. It's good practice until you can get it good every time, but like I generated these and I made them too long. I shouldn't have done that, but it's too late now. All right. Next, find each product. Oh yeah, also, me saying that is saying like, don't expect to see 4 of these on your test. All right, find each product. Well, here, it's got a 3 out front of that, so you just distribute the 3. So 3 times 2x is 6x, and 3 times the plus 1 is 3, so 6 plus 3. And then on this one, remember how this works. When we do 3x squared times 5x, we do 3 times 5, and we get 15. Then we have x squared, which is x, and that's 1 more x. So that's x, x, x. That's 3 x's, x to the 3rd. So now when we do 3 times -4, we get -12. And there's an x squared and nothing, so we get an x squared. All right, I'm gonna do this one way, I'll do this the other way that I've taught. The first way is we take the x times the 2x, and x times 2x is 2x squared. We're just distributing. And the x times the -2 is -2x. And then we will take the plus 6 here times the 2. So that's plus 12x. And then 6 times the -2 is -12. And then we look and we see, hey, do we have any like terms? And sure enough, in the middle, I've got these -2x and this plus 12x. -2 plus 12 is 10. So I have plus 10x. The -12 just comes down and the 2x just comes down. So there is our simplified answer. Our simplified expression. All right, so the other way that we can do these is by setting up a lattice, which is a fancy way to say a box. So I can do the 4x plus 1 on one side, and when I teach it, I try to do the first one on top every time just for consistency, but you can put the 4x plus 1 over on the side, it doesn't matter. And then my 5x and my -6. And now we're just Punnett squaring it, right? We're doing the two things together here. So 5 times 4 is 20, and x times x is x squared. Then 1 times 5 is 5. Oh, and there's an x, and it's positive. So you can put a plus there to remind yourself if it's helpful. You don't have to. Some people like to just leave them blank and then only put negatives in when they're negative. Like 4 times -6 is -24. And then there's an x shared there. Or they have an x total. And then 1 times 6 is minus 6. And the thing that can be really nice about the box method is it can be a little bit easier to find like terms. So negative 24 plus 5 is negative 19 of those. So I could write my final answer is 20x squared minus 19x minus 6. So, all right. Quarter of the way through. This will not be a 40-minute video, though. I can almost guarantee it. All right, so number 9. Now that we're on this one, do it however you want. You can do 4x plus 1 up here, and then 2x squared, 3x, and 7. They're all positive, so you don't have to like write pluses. You can write pluses if it's helpful. We just got to fill the boxes out, right? So 4 times 2 is 8. We got x and x squared, that's x cubed. We got 1 and 2x squared, so that's plus 2x squared. Next, I've got 4 and 3 is 12 with double x's, so x squared. And then here 1 and 3 is 3 with an x. Here 4 and 7 is 28. And there's a single x. And then bottom right is 1 and 7, which is 7. And again, the box is pretty cool for this because a lot of times, the way the like terms will work is they'll just be these diagonal pieces together. So 12 plus 2 is 14. That's 14x squareds. And 29 and 3 is 32. So we have 32 x's. So our final answer then, we've got 8 of the x cubes. We've got 14x squareds, we've got 32 x's, and we've got 7. Cool. So 10 is a similar thing. Oh, I forgot to check my answers as I went. All right. Yeah, we're good. Okay. And then that one's... Oh, I made a very silly baby mistake. Did you catch it? That 4 times 7 is 29? I don't know why I wrote that. That's 28. And then 28 plus 3 then is not 32, that's 31. So sorry about that. I missed it while I was doing it. So the thing is, if that was your final answer and you had all that stuff there and this was a 5-point question, you would get 4 out of the 5 points. You know what you're doing. That's a baby mistake right there. Everything else is very clear. So 10, you could do it, you could use another box. You can also just do the 6 times each of them like this. Like that. Maybe I'm better at that. I don't know. So 6 times 7 is 42x cubed. Then 6 times 7 is 42x. Then 6 times 7 is 40. Oh, wait, that's x squared. And then 42x. Then minus 3 times 7x squared is minus 21x squared. And then minus 21x. And then minus 21. And so our final answer that I get for this one is 42x cubed plus 21x squared, because the 42x squared minus the 21x squared gives us 21, and then minus 21x, and then minus 21. So the same kind of thing happens there. All right, factoring time. Okay, so I want to be consistent. I'm always going to be looking for numbers that multiply to equal the last one here. And it's not cool for me just to go, oh, this first one, and I find the answer and I don't really tell you what I'm thinking. So when we're doing this, we're looking for things that multiply to equal the last number. And at the same time, one of those pairs is going to add to this 14. So like I could do 1 times 48, but that adds up to not 14. That adds up to 49. So that's not going to be our answer. Whoa. Hello? Whoa. Oh dear. Has it been this out of focus? Sorry. All right. Okay, so anyway, 1 times 48 is 48, but 1 plus 48 is not 14. So you gotta just try different combinations. And if you were getting stuck, seriously, tried and true. 48 divided by 1 is 48. So like 1 plus 48 is 49. That's not 14. 48 divided by 2 is 24. 24 plus 2, like, because I know 2 times 24 gets us 48. That's why we're dividing. Well, then 24 plus 2, what's that get me? 26. Okay, no, it's not. Well, just 48 divided by 3 evenly? Oh, it does. It divided by 16. 3 times 16 gets me 48. What's 3 plus 16? 19. I'm getting closer, but that's still not what I want. All right, let me try 4. 48 divided by 4 is this it? Oh, wait, hold on. 12 plus 4. No, 16. All right. 48 divided by 5. Maybe that. Oh, wait, that doesn't go in evenly. All right. 48 divided by 6. Let's see. What's 6 plus 8? Hey, there's our. So 6 and 8 were the two numbers that multiply to 48 and add to 14. So I'll do x plus 6 and x plus 8. And you can do either order. It doesn't matter. These are the same thing. And that is all I'm going to do on this page. The thing is, sometimes things get screwy on us. So I need 80. So I can go through, I already know the answer. I can go through and I can try things. Like I can try 80 plus 1. Wait, I'm supposed to get negative 18 and I'm doing 2, we're gonna have an issue here. Well, let's keep on going. Let's see. So the 2 is 40 and 2, so it's 42. 3, I don't know. No, just 4? 4 and 20? It's 24. It's no. 5 and 16 is 20. Well, it's getting closer. Those don't work. So like, I immediately was like, oh, 80 is 8 times 10. Oh, 10 plus 8 is 18. That was the first one I thought of, but I'm saying if you don't think of those, here's how you can kind of go through and check. One more thing. 9 got me that, but 10 goes, now we're back to 8. We've already done 10 and 8 earlier. So the only ones I'm going to get left now are ones that I've already gotten before. I'm not going to get anything new now. So that's like there's going to be a point when it switches over and you're like, oh, okay, I've looked at enough. So the problem is I'm going to multiply to a positive 80 and add to a negative 18. So like if I just do 8 plus 10, that's not negative 18. But if I do negative 8 plus negative 10, that's negative 18. And negative 8 times negative 10 is positive 80. And so a negative times a negative still gets me that positive. I still almost wrote plus there for some reason. X minus 8, X minus 10. And then the trickiest kind that we can see on this, oh, sorry about the earthquake, is ones like 13 and 14, where now I have to multiply to a negative. And the only way to multiply to a negative is with 1 plus and 1 minus. So here, 72, you can try, well, 70, I know, like 6 times 12 is 72, right? So let me try making one of them negative. Negative 6 plus 12, 6. Oh, wait, there's no number there. It's a 1. So I need to multiply to 72 somehow and get a 1. Well, how do we get 1 when one's plus and one's minus? Well, when they're really close together. And so if you know your times tables, like 72 times, I already tried 6. 8 times 9 is 72. So what if I did negative 9 plus 8? Have the 9 be negative. Oh, that gets me negative 1. That just means switch it. So that means instead have a positive 9 and a negative 8. And now it'll work. So x plus 9, x minus 8. So the way we do is a little bit faster. Same idea though. Okay, so I'm multiplying to negative 12. That means I need a plus and a minus. And then I got to add to negative 4. So I need the bigger number needs to be negative. So I'm thinking 6 and 2, because 6 times 2 is 12, and 6 minus 2 is 4. And then we just, since we need the 4 to be negative, we'll make the bigger number negative. But again, when in doubt, use the calculator, it's your friend. 15, let's see, I gotta multiply to 40, probably 8 and 5. 8 times 5 is 40. And 8 minus 5 is 3. Oh, it's just, so it's positive 8 and it's negative 5. Let's see, this one, I was gonna do 6 and 4, but 6 minus 4 is 2. 6 minus 4 isn't 5, so that's not gonna work. So what could it be? 24 divided by, I already did 6 and 4. What about 2? Negative 12 plus 2. No, I need to get a 5. Well, what about negative 2 plus 12? No, it takes me positive. That didn't work. Ugh. Okay, all right, try 3. Oh, wait. Okay, hold on. This is me pretending. I already figured it out. I'm so smart. It's like I'm a math teacher or something. It's like I do this for a living. So we're trying to multiply negative 24. 8 and 3 do it, and then if I make the 8 positive and the 3 negative, then they'll add up to 5. There's an element of kind of guessing and checking that we can do as we go. All right, now we have 56 with a 1 again in the middle. That 1 is my little personal cheat code is, oh, that means the two numbers have to be 1 away from each other. And 56 is 7 times 8. Let's see, so I want we're going to end up with a positive, so we want the bigger number to be positive, little number to be negative. I'm just going to check my answers, make sure I didn't do something silly on any of these. Yeah, everything is looking like I know what I'm doing. So 17, 18 are friends, because 18 also has 56 and is also 7 times 8. But this time we're adding to 15, which if they're both positive, that works. 9 is 4 and 5. And, 19 is 4 and 5. And then 20, what is that, 10 and 2? Nope, 12 and 2. No, it's got to add to 2. That was just 6 and 4. So you can always play around. 4 times 6, 24. And then I can try negative 6 plus 4, negative 4 plus 6. Like, you just toy around until you get it. And you will get it. If it's possible. And I haven't put any impossible ones on the test, and I don't plan to. All right. 21 through 26 was just a review of basic trig to see if you've got this in your mind. If it says sine of theta, well, here's my theta. Well, then, let's see. Well, here's my right angle. So there's my hypotenuse. That makes this opposite. And then that's my adjacent. Well, and if I'm asking for sine, I just want opposite over hypotenuse. Opposite was 24. Hypotenuse was 25. Done. So that's all we do for these. Tangent theta, so tangent is opposite over adjacent. Well, here's my hypotenuse because it's across from the right angle. Opposite's 8, and adjacent is always between the angle and the right angle, so there's my adjacent. So O over A is 8 over 15. So same deal here, and theta's even in the same spot, so this one's just 4 over 3. Here my theta's here, so opposites over here, and hypotenuse is up here, so 20 over 25, because it's sine. Cosine, here's my angle, so there's opposite. Adjacent's between the right angle and the angle, so there's adjacent, and then 20 is across from the hypotenuse. I mean, 20 is across from the right, the hypotenuse is across from the right angle, that's what I'm going to say. So cosine theta would be 12 over 20, and you could simplify 12 over 20. They're both divisible by 4. And get 3/5. But I've accepted, for these basic trig ones, I've accepted just whatever fraction it works out to. This last one here, cosine is adjacent over hypotenuse, so my adjacent is one of these. Oh, it's the adjacent one that's touching the right angle like that. So 12 is my adjacent, hypotenuse is 13 because it's across from the right angle, so 12 over 13. All right. Yeah, we're almost done. I know it might not feel like it, but we really are. All right, 27. Sue. Find the measure of each indicated side. Well, whatever. Okay, well, I got my angle here. So I know this angle, so then that means I can say that is, here's our hypotenuse, here's our opposite side, here's our adjacent side. Well, if I'm doing SOHCAHTOA, I have opposite and adjacent, that's tangent. So I can say tangent of 73 is equal to opposite over adjacent, x over 4. And then to finish it up, I'll just multiply both sides by the exponent and get 4 tangent 73, and I get, I'm going to go to mode real quick. I'm just going to make sure, yeah, I'm in degree mode. We're good. 4 tangent 73, and I get 13.08. It says round to the nearest tenth, so that would be there. 13.1. Okay. Next, here's my x. It's across from the right angle, so I know it's hypotenuse. And then this one's touching both the angle and the right angle, so that's my adjacent. So h and a, let's see, that goes along with cosine. Cosine is a and h. So I can say cosine of 62 is equal to a over h. All right. And in this case, now x is on the bottom, and so the algebraic shortcut that we talked about was just those trade places, and x is equal to 15.3 over cosine 62. So, but I've usually will write this in my academic class. I'll write 15.3 divided by cosine 62. And no, you're not going to do this in your head. Because cosine of 62 is this fun number. So 15.3 divided by cosine 62, I get 32.6. Next. Let's see, I've got my angle here. Oh, here's my right angle, so I know this is my hypotenuse, and then my angle points to the opposite. Okay. O and H, oh, that's sine. So I can say sine of 56 is equal to, pardon me, 9 over x. And so now, which of those situations is it? Well, x is on the bottom, so it'll end up being divided. So 9 divided by sine 56. 10.9. All right, and then our last one here, 49, looks like it's tangent. Tangent 49 is equal to 16 over x. Okay, looks like we got another division one. 16 divided by a tangent 49. And I get 13.9. I did not even think about checking any of these. Let me see if I'm okay. All right. I'm checking the top of the paper too. Yeah, looking fine there. Okay, on to the last page. So these ones ask for the indicated angle. All right. Oh, excuse me, I'm putting myself to sleep. So here, I've got 2 out of the 3 sides. There's my opposite side. There's my hypotenuse. So that means this is the adjacent side. I've got O and A. Hey, that's tangent. So I can say tangent of my angle, which in this case is theta, is equal to O over A, 6 over 10. So to find out what theta is, we just use inverse, which on this calculator, you push second tangent and then just type the fraction, 6 over 10. So theta is equal to inverse tangent of 6 over 10, which is a 30.96 degree angle. It says round to the nearest tenth, so that's going to round up to a 31.0 degree angle, because the 9 rounds up. Let's see, 32, is it tangent again? Because that's our opposite. Oh no, that's our hypotenuse. Opposite and hypotenuse, that's sine. So I can say sine of theta is equal to 7 over 8. Then I'll just use inverse sine. Seven over 8 gets a 61.0 degree angle. This one, I don't have opposite. Let's see, angle and right angle, so that's adjacent. And then there's my hypotenuse. So I have AH, that's cosine. So I say cosine theta is equal to 2 over 4. And so then we'll do inverse cosine of 2 over 4. 2 over 4 is 1/2, which should give us, what, a 60 degree angle then? All right. Yes, I did do that in my head, and yes, that is something you will eventually learn. You'll learn that in pre-calc, I believe. So that is exactly a 60 degree angle. It's part of our 30, 60, 90 triangle. All right, and then 34, excuse me, looks like another tangent. So tangent theta is equal to 15 over 6. So we'll say inverse tangent of 15 over 6. 68.2 degrees. That 1 takes the 9 and rounds up to 2. All right. This one says, find all missing sides and angles. This is an honors only thing that we did. And the way that we handled this was, I don't even know. I don't know how to do this. You just write the answers. Let's see. This is 2. No, I'm just kidding. So you pick. It says all missing sides and angles. Well, here's a 40 degree angle. There's a 90. 40 and that together have to add up to 90. So that's just 50. So like there, I found the angle. Wow. I'm a genius. But I still need 2 here. So what I'll use is I'll use this. You can pick either angle, doesn't matter. But if I name this angle as the one that we're going to use, well then 2 is my opposite side. And then I want both of these. I don't care which one I start with. I'll pick this one. That's my adjacent. So I can say tangent of 40 equals 2 over x. It's just what I picked. There's a whole bunch of different setups. I could have instead done the 50 and said tangent of 50 is equal to x over 2. I could have said sine of 40 and used the hypotenuse and found the hypotenuse first. These are going to end up having the same answer. 2 divided by the tangent of 40 is 2.38. 2 times the tangent of 50 is also that exact same number, because it's 2 different ways to get the exact same number. It doesn't matter which one you do. So I'm going to write 2.38 here. So now I've got a 2 and I've got a 2.38. So now I can find my third side. A few ways you could do that. You could set up another trig problem. You could say sine of 40 is equal to 2 over, I shouldn't use x again. I can use y, or I can use c, or just some other letter for clarity's sake. So then 2 divided by sine 40, and I get my third side is 3.11. there we go. There's everything missing. So that's one way to do it. Another way that I could have done this after I got the 2.38 is I could go, well, I know that 2 squared plus 2.38 squared is equal to that third side squared. And I can just use Pythagorean theorem, right? So 4 plus 2.38 squared is 9.6644. So when we take the square root of both sides, I get square root of 9.6644, and I get 3.108, which rounds to 3.11, which is... So we're going to have some round off error if we do. Whenever we round mid problem, we end up with slightly different answers. All right, this one. Let's say you want to find the third side without having to find the angles first. Well, you just do Pythagorean theorem, right? 2 squared plus 5 squared is equal to c squared. And 2 squared is 4, 5 squared is 25, so 29. Square root of 29, which 5.39. Okay, there, I got all three sides now. Well, okay, well, let's find the angles then. Okay, so here's B. If I call this theta, then 5 is my opposite and 2 is my, tangent. Tangent theta is equal to 5 over 2. So then inverse tangent of 5 over 2 is, that's a 68.2 degree angle. So let's say theta, 68.2. And then you find this one by doing 90 minus that number and get 21.8 degrees. There you go. That sounded like I was barking. Oh my goodness. All right, I'm tired. So hopefully that was helpful. Oh, it was almost a 40-minute video, but hopefully it covers it in depth. Feel free to let me know if you have any questions, and I'll see you on Friday. Good luck. Bye.